Hello everyone. In this video, I will explain to you how to use Excel to conduct a versioning price optimization. This is the same example we have discussed in class. Two market segments exist, accountants and casual users. There are 1 million accountants and 2 million casual users. The willingness to pay to two different versions of the accounting software, Premium and Standard, are in this area. Given this information, our goal is to find out the optimal prices to offer in the marketplace in order to maximize the total profit. In this region, I have prepared data layout for our optimization. Index 1 and 2 are referring to the two different software versions, and the prices are here. So these two cells, D8 and E8, are where we put the optimized prices. And in cell D9, we put the total profit. This is the number we will ask solver to maximize. First, we start with calculating the surplus that each segment gets from the two different versions of the software. Surplus for Premium and Standard. And then we're going to calculate the maximum surplus between these two. So for Premium, the surplus is equal to the willingness to pay minus the price that we put here. So in order to make this formula easier to copy around, we are going to lock it down in row 2. So instead of D8, we have D$8 and return. So this gives us the surplus of accountants for the premium version of the software. In this case, the surplus is 200 because the current price numbers are empty, so they are treated as zeros. Let me put in a couple of small numbers just to fill it up so that we get some sense that the surpluses are not exactly equal to the willingness to pay. Now this formula is readily copyable. So now we have the surplus numbers. We're going to calculate the maximum surplus out of these two versions for each one of the segments. All right, so after we get the maximum willingness to pay, next we're going to calculate how each segment make choices based on their largest willingness to pay. So the selection is equal to match. We'll find the maximum willingness to pay from these two willingness to pay numbers, and we're going to fill 0 here. It will give us the exact match and return. So here, as you can see, the maximum willingness to pay is $180. Is equal to the premium version, so match returns the first number. If max is 70, then match will return 2. Next, we need to address the condition when the maximum surplus out of the two is still negative. So we call this segment development. So if a segment does not buy either one of the two, if the maximum surplus is negative, then we don't expect the segment would buy anything, although the selection would still give us one of the options. But since both options are negative, we need segment development to address it. Here, we're going to just use an if condition. If the maximum surplus is less than 0, then there's no segment development, so it's 0. Otherwise, we do segment development, it's 1. And copy this. And finally, here we want to calculate the segment contribution. That is, based on the choices of both segments, we want to calculate how much each segment is paying. So here we're going to use a command called HLOOKUP. HLOOKUP refers to horizontal lookup. It's going to look for the selection number in an area that is including index and price. So if HLOOKUP sees a 1 in this area, it's going to find 20. If it sees a 2, it's going to find 10. That's what HLOOKUP does. And since we want to copy this formula, press F4 key to lock up both columns and rows. The row index we'll look for is the second row, where the price number is. And there's a final option, which you can, but you don't have to fill in, is whether you do a range lookup or an exact lookup. So we don't do a range lookup, then we put false there. If you don't put false by default, it's not going to do a range lookup return. And this, we can copy this down. And this number is indeed a dollar number. So since both segments are selecting 1, we're going to find two $20 price numbers. And these are the contributions. And the next, we're going to calculate the total profit. The total profit is the segment size for each segment multiplied into whether the segment buys at all and multiplied into their contribution. So here we're going to use a command called sum product. Product here means multiplication. What this command does is it's going to do the multiplications first and then sum up all the numbers multiplied afterwards. So what it does is it's going to use these two segment sizes multiplied into segment development, yes or no, so there are zeros and ones, and then finally multiplied into the contribution. This gives us the total profit. Okay, now we have set up the problem. Next, we'll go ahead and solve it using Solver. So go to Data, Solver, and here we're going to set objective as the total profit, and to maximize it by changing variable cells are the two prices. And the next, we want to set constraints in terms of the prices, how high the prices can go. Here, the easiest thing to do about constraints is to look at the willingness to pay numbers, because it's meaningless to set prices above the highest willingness to pay in the market, because nobody would buy. So for the price of the premium version, it should be less than or equal to 200. And for the price of the standard version, it should be less than or equal to 80. And click OK. Now if you see the interface, what you get is these two constraints have been set. And by default, you'll make unconstrained variables non-negative. And next, select the solving method. Here we need to use the evolutionary solver. And click Options just to check whether the solver is properly set up. Okay, the default setup looks fine. The evolutionary solver setup, these are the default settings. You can make some changes, but sometimes it makes very little difference. The only number that you should change is the maximum time without improvement. For this one, I would recommend you to set at least 300 because for large-scale problems, you need solver, especially evolutionary solver, to spend more time to search for the solution instead of letting it come out too soon. And click OK. This sends you back to the interface before, and then click Solve. Now Solver is going to start. it is done. As you can see, the solution is almost the same as what we have solved manually in class. This concludes how to use Excel to optimize price versioning. Thank you. I'll see you next time.